Alrighty, last video of the year. I believe if we were drawing in emojis, it would look like this. I think there's maybe some confetti. Maybe this is striped. This is the party emoji. So yay. Alright. I'm actually going to make a pretty short video and leave you guys plenty of time to start rolling through these problems on your own. And then if you guys have questions or whatever, you get stuck on a problem, you can let me know. I will try to work all of the problems that I assign to you out and get those answers to you, and then for sure we'll work on it at Monday's work session. But just in case some of y'all are not going to be able to come to that, I don't want to sort of disadvantage anybody who doesn't isn't able to make it to that and therefore has trouble with the final or whatever. Okay, so we're going to get you all the resources you need to make 100 on this. So if you have this sheet that I sent whenever that was, Tuesday, I guess, make sure you've got it out. But even if you don't have it, you can just write this and then whatever we talk about right next to it, so you have a little more clarity on it. Generally, my approach to finals is that they should hit all of the highlights from the year, and you guys should be thinking throughout the year, what are the main ideas, what are the high points, what are the big ideas, and it won't be so much focused on specific problem solving, but there will be a good bit of vocabulary, there will be some problem solving, but it will be pretty clear what those problems are, and I've noted these down here, what numbers I want y'all to work for these. So I'll either take a picture of this and upload it to ClassReach, or scan this tomorrow, or somehow get this to you, because even if you don't catch everything, you'll have that. But I'm going to say some stuff that go along with my sort of final philosophy to help you be prepared, that maybe I don't specifically write on here. So make sure you're listening, make sure you're taking notes that are going to help you remember what it is that we talk about today. Alright, so just kind of starting with, it seems that the general consensus at the school is that unless something is super foundational to a subject, we should really only be testing the second semester at the final for the year. That's fine. I really think you guys are old enough to be accountable for the whole year, and we'll try to talk about that at the beginning of the year in physics next year, so that you are keeping up with stuff, because I think I talked to 3 or 4 different people and they're like, yep, I don't have any of my old tests. You should keep your old tests, okay? Because if I put it on a test before, I'm likely to show up on a test again at a final or a semester exam. So just a sort of a tip there, and that'll help you kind of as you move into college, where you're going to have less structure to when they review stuff for you. They're just going to tell you that everything you covered in the year is on the final, and make sure you know how to do everything. Like if you were in chemistry, there wouldn't necessarily be a study guide. It would be like, yeah, we covered chapters 1 through 15, and remember how to do stuff from 1 through 15. Because that's what they want you to do. They want you to take away the whole knowledge of the subject. They don't want you to just be kind of spoon-fed all the time. But you're not in college yet, so we're going to do just a little spoon-feeding today. All right, so without further ado, all right, lone pairs of electrons. You need to kind of understand what are they? So what does that mean? All right, so that's remember we talked about in water let me actually do this. I'll switch back and forth here. So we got H2O, right? And what is that? That's an H, O, and an H. And it turns out that when we do our Lewis diagram, because we know that H is, each one of those is bringing 1 electron, so that is 2 electrons total, and oxygen is bringing 6 electrons. There's only one of them, so we have to distribute 8 electrons. These are 2. These are 2. Hydrogen's happy because they only want 2 electrons. Hydrogen's happy because he only wants 2 electrons. So we got 2, 4. Well, we got to get rid of 8 electrons in the valence. So we got to do this. Okay, and then we have 1, 2, 3, 4, 5, 6, 7, 8. And then oxygen has 8 electrons. Check. And hydrogen has 2 electrons. Check. All right, so now everybody's happy. This is a stable Lewis diagram, but what do we have? We have non-bonded electrons right here. Okay, and remember on that oxygen, it actually looks like this. Got a lot of electron, got a lot of negativity in here. Okay, this is like when those people who look into a crystal ball, the gypsy might come along and sense a lot of negativity. That's what's going on right here. All right, so that's, we end up with these partially negative and positive areas, and of course that means what? This is a polar molecule, and also of course it means what? If we have another hydrogen nearby, we get hydrogen bonding. Okay. So anyway, that's the kind of thing that you need to be understanding here. So when do they appear? They appear when we've got extra electrons left over in the valence after everybody's satisfied and has the electrons that they need. Okay, but you can look that up, read through, make a flashcard, do what you need to do on that. All right, all the shapes on page 154. Okay, so your question is going to be, how is this going to be tested, right? That's a good question, because that's what you're going to have, a test. So probably what we'll do, again, because we're trying to cover a lot of material, not super in depth, but kind of skim along to keep the highlights there, you need to be able to look at a drawing and tell what it is. Okay? And so you need to know kind of both of these things. And I'm just going to tell you the easiest way for you to remember this is to actually understand what geometry these shapes are. So there are videos. Type in Vesper on YouTube. Plenty of videos. Nothing crazy about it. Okay? Look at this right here. And look at these right here. And remember what's going on. Remember why they're called what they are. Okay, so we got linear, means that they're all in a straight line. This might actually be better here. Okay. Trigonal planar, what's that mean? It's all in a plane. And it's in a triangle. So triagonal planar gets shortened to trigonal planar. Tetrahedral, this is a tetrahedron, meaning it's got this shape. Okay. You don't have to know any of these numbers, although that shouldn't, again, be super hard to remember. With the 180, the 120, you might have trouble remembering this. Okay. But, not that big of a deal. All right. Trigonal, again, triagonal, triangle, bipyramidal, so one pyramid here and one pyramid here. That's what's going on right here. All right, and then octahedral, that's an octahedron. Okay, so not a lot of mystery here. It just is, it's going to require work for you to reactivate that knowledge in your brain. Okay, and remember that something like this, because of those electrons, they repel, and that ends up getting bent downwards. Okay, what might have been flat before, those electrons, which are kind of up here, push and repel the other atoms, so that gets bent. Okay. All right, and again, there's tons of videos on that online that have got the 3D. I shared one at one point, but I think it was during a class, so that might be kind of hard to find for you. But check out the YouTube video. Just type in Vesperd literally, and there should be something that'll help you get back into that. So just remember that, you know, even though water looks like it might be linear, it's actually got the extra electrons, so it's bent. But probably going to give you one of these and ask you to identify these. Okay, so not a whole. You're not going to have to do Lewis diagrams, so don't spend your time doing that. Though that is important. There's just too much else to cover for us to all get stuck on doing Lewis diagrams. All right. Study page 161 for hydrogen bonding. You need to know that that is the strongest of non-molecular bonds, right? So that's what makes water boil at such a high temperature, because those hydrogen bonds are holding those molecules together, even though they're not molecularly bonded in a covalent bond or an ionic bond. It is a very strong bond outside of that. Okay, read back over these, make note cards, be able to identify which one's the weakest. And be able to tell me what they arise from. Okay, very straightforward. Okay, precipitate, you need to know what it is. Law of conservation of mass, what is it? Be able to state it. Be able to fill in a blank. If I give you that law, I'm not sure what direction we're going with that. Okay, I might ask you to write a couple of sentences on why it helps us with balancing equations. Limiting reactant, you need to know what it is. I think I've actually got some problems that you need to do on that. Okay, so we'll talk through those. You need to know what this is and what it means. You need to know what that is and how it references chemistry. You need to know that pressure is a force divided by an area. Okay, and maybe even solve a simple problem. Okay, and that would be giving you some force, and you know the pressure that it results in, so you have to solve for area. Okay, really straightforward stuff, but that's going to set us up really nicely for next year. Okay, because we're going to get into this a little bit more heavily. 4 states of matter, and I say here including their volume and shape distinctions. And so what do I mean by that? By that I mean we have gas, and what is that? That's no fixed volume, no fixed shape, right? Gases fill any container they're in an even manner. I'm giving you guys crooked video here. It's driving some of y'all crazy. Sorry. All right, no fixed volume. All right, so then a liquid, what is it? You know, it's no fixed shape, but it does have a fixed volume, right? You pour water in glass, it doesn't fill the glass and then fill the room like a gas does. Okay, and then solid is fixed shape and volume. Okay, so think through that, what those mean. Okay, I may ask you to come up with those. I may ask you to identify something as a gas, liquid, or solid, or I may say, hey, a gas, tell me about its volume and its shape. What are they? And you'd have to say neither one of them is fixed, right? Pretty straightforward, but if you don't look back over it, you'll be struggling to pull that out. Okay. All right, then you need to know, of course, the 4th state of matter is plasma, as our friend Nemo would remind me so kindly, that there's also plasma. we're not worried about any of this stuff with plasma. We just need to know what it is, and you need to know that it's ionized particles. Okay, and so just know that, look it up, read through it, make a note card, and memorize it. Okay, diffusion, just basically a definition. All right, be able to do this diagram. Y'all remember that? We had solid, liquid, gas, right? And then we had arrows. And what is it? So gas to liquid is condensation, evaporation / vaporization. Okay, I'll accept either one. This is a better term. All right, solid to liquid is what? Freeze. Liquid to solid. Sorry, this is freezing. And then this is melting. And then gas to solid is what? Deposition. And then solid, sheesh, this one, all right, deposition. And then solid to gas is sublimation. Okay, all right, that was awful, but you guys have that. You should make note cards or be able to draw that. Test yourself, draw it, and then be able to fill in all 6 words. Okay. Y'all work together, get that. This is an awful diagram here, but there's nothing hidden or confusing about it other than my handwriting there. All right, so you've got those words all here. Make sure you're able to call them from your memory. All right, volatility, just need a definition. You need to know that this is the relationship here. That pressure in the gauge plus the pressure in the atmosphere is equal to absolute pressure, and be able to work simple problems. Okay, easy to test yourselves on these. Okay, need to know these words: soluble, miscible, dissociation, hydration, exothermic, and endothermic. More note cards. Entropy and Gibbs free energy. Okay, you need to know what they are. And basically what you need to know about this one is that this is what's minimized by any chemical reaction. The Gibbs free energy is. And I should say by any chemical reaction that is spontaneous. That if you put things together, they will go by themselves without you having to heat it or mix it and or agitate it or put in a catalyst or anything like that. All right, you need to know saturated and unsaturated, solubility, and I said be able to read chart and answer questions. Okay, I'll try to send that homework out. That way you guys can, I'll say send old homework out. Okay, that way you can have that right where you need it. Okay. All right. So that's the super, well, I say basic, but that's the sort of memorization / simple equation stuff for you guys to be looking over, making note cards, checking out. Okay, memorizing. All right, then these are the things that are going to require a little more engagement and work. Okay, so how to write a chemical equation. I guess that probably could have gone up here because it's just sort of, you know, memorizing how to do stuff. Okay, but look, when you see an equation in the chapter, like right here on page 171, okay, it's a good thing to look at and see what is called out here. We've got states of matter, it's balanced, We've got this delta above, which indicates heat. Okay. You need to be pretty familiar with these, okay? With all these right here, because we use all those, and to have a basic working knowledge of chemistry, you need to be familiar with all of those things. All right, so likely that will be tested by me writing a word equation and telling you to write the equation. You know, liquid mercury is mixed with gaseous oxygen and burned at 250 degrees. Okay, well, you know that it's got to have an L by the mercury. It's got to have a G by the oxygen. You know that oxygen needs to be O2. All right, so we got reaction notation, page 172, and I'm going to add to that the rules on page 173. Okay, so formulas need to be correct. All right, and maybe some basic ones will be required of you. I will not require a bunch of memorization all of a sudden here on stuff that we have not done in a while. That's not super helpful, okay? But I will give you the you know, if I ask you for phosphoric acid, I'll tell you that's H2PO3, okay? If only just to make you balance it, all right? And so but like water, duh, H2O, all right? But you need to know these 7 diatomic substances, HNOFClBrI, okay? And if you remember, it's boop, 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 and then hydrogen. Okay, that's pretty easy to remember which ones are diatomic. But anytime you see them by themselves, they are always an H2, N2, O2, F2, Cl2, Br2, I2. Okay. Okay, then you see those rules, so look through those, internalize what they mean. You'll need to be spending some time back in here to get back with this, okay? Oxidation states. I'm going to talk to you all about this here, okay? We had a lot of trouble with this on the test, I remember. Okay? You get these rules over here. I know it's been a long time since we've done that, but that's sort of the point, is to make you learn it a second time so that it really at least sticks 20% better than it would have otherwise. Okay. I will work through some of these here and talk to you about what's going on in those. Okay. Because I think that's helpful. But trying to decide whether I should do that now or whether I should do it just Monday after you guys have kind of grappled with it a little bit. Okay, well, we'll see how much time is elapsed by the time I get through all this, okay? Balancing equations. Again, I'm going to send this out to you, I'm going to send out a list of the problems you need to be working. Okay, balancing equations, chapter 7, number 13. Just practice. There's no mystery to balancing equations. No one's confused about what we're doing there. Sometimes it's just a little difficult to actually do it. Okay, so you just need to re-practice doing it. That's all. All right. Types of reactions. Okay, you need to be able to identify the types of reactions. What are those? All right, if you flip over to 180, we've got synthesis, and then decomposition. And what's the best way to be able to do these is to be able to say, you pull up a note card or a Quizlet, whatever, and it says decomposition, and you are able to write AB goes to A plus B. Okay? And to be able to write it in that general form lets you know that you are able to identify it no matter what's going on. Okay, so we got synthesis. A plus B comes out to be AB. Two different things form one. Something is synthesized, which means it's made. Decompose, dead bodies decompose, they fall apart. So you have a dead body and it goes down into its constituent parts. AB breaks down into A and B. All right. Got the activity series. If I ask you questions about this, I'll provide you this, but you need to refamiliarize yourself with the activity series. Okay? So you know when a reaction will happen or not. If you remember the more active ones, pointing off screen there, the more active ones will displace less active ones. If you've got a compound with this and this is introduced, he comes in and he knocks out the partner of like aluminum and takes its place, okay, because it's more reactive. It wants those bonds more than the first metal does, okay? All right, so we have single replacement. That's often what happens when we've got an activity series is you're going to see a single replacement because it's going to come in, if this is lithium, for example, he's going to come in, he's going to bump B out of the way, and then B is going to go and be in solution, and these are going to now be bonded. Okay, but only if A is higher up on the activity series than B. This single replacement doesn't only have to be having to do with the metal activity series, but that's a common situation. Okay, and they show you an example right here. What's happening? You can confirm what's going on based on the activity series on the previous page. Okay, that's single replacement. Double replacement. All right, I know a big part of the confusion was on the test, at least, if I remember correctly. It's been a while for me as well, obviously. Was identifying something as a combustion versus maybe a synthesis or a double replacement or something like that. Okay, if it has the product only CO2 and water, and it is a hydrocarbon and oxygen, that's combustion. If it doesn't have all those, it's not combustion. If it does have all these, it's 100% combustion. Okay, that's not a double replacement or synthesis or anything like that. That's combustion. So you need to know that it's a hydrocarbon and oxygen, goes to CO2 and water. Okay? So, and it does say one important exception, combustion of hydrogen, which is a synthesis reaction. Okay? So, you know, I'm not going to put that one on there. Or if I do, I'll accept synthesis or combustion, because those are both true. Acid-base neutralization, we didn't really put that in the same category as the other ones because they tend to be like a double displacement, but whatever. And we've talked enough about those recently that you shouldn't have any problem with that. So basically you've got synthesis, decomposition, single replacement, double replacement, and combustion. You should have 5 types that you'll deal with there. Okay? All right, stoichiometry, not much to it other than you got to, not much to it conceptually, a lot to it to be able to work the problems. Okay, so if you'll remember, this is where we do the mole ratios. We go from grams to moles to grams. Okay, and that's always the pattern. Okay, and so you have the same roadmap: grams to moles to grams. Okay, now sometimes you won't ride the bus all the way from the first to the last. You'll start here and go here. Or you'll start here and go here. You'll start here and end here. You'll start here, go all the way here. Okay, but it's always, if you're trying to get from grams of reactant to grams of a product, you got to go grams, moles, moles, grams. If you're given moles of a reactant and you're trying to get grams of a product, you just start here, moles, moles, grams. Okay, always the same order. Okay, so make sure you're doing that. Okay, and so that's where if we start with, 10 grams of water reacts with something, 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 first thing you got to do is you got to say 1 mole of H2O is what? It's 18 grams of H2O. Grams, grams cancel out. And if you were just doing this conversion, that's all you do, 10 divided by 18. Okay. But then if we wanted to see how many moles of product there were, we'd fill this in here, and then we'd end up with, whatever, grams of product there, and that would be our total answer. We'd multiply and then divide, okay? You're going to need to get back into this, working these problems, okay? And that's why on stoichiometry, I've got chapter 7, number 22 called out right there. All right, limiting reactant, it's the one that runs out first, right? So if you're making a cake and you got X number of eggs and an infinite amount of flour, you can only make as many cakes as you can until you run out of eggs. Eggs are your limiting reactant, okay? You're short on flour, but you got a ton of eggs, or maybe you got some chickens in the backyard. Flour is going to be your limiting reactant. You go along with the recipe, making what you need to make until you can't anymore. And when one of your things runs out, you know that's what is your limiting reactant. Okay, so if it takes 2 eggs for every pound of flour to make a cake, and you've got 5 pounds of flour and 4 eggs, your eggs are going to run out first. So you can predict how much flour you're going to use. You can predict how many eggs you're going to use. You can predict how many cakes you're going to make. Okay, based all on that limiting reactant. Okay, get into that. We'll talk more about that. You're going to need to have some be able to answer a word problem like, hey, look at these 2 atoms and tell me which one is going to have the lower average speed. Okay, and that's just coming from this distribution right here that can be made for any number of gases. Okay, go back, read that. How to read a phase diagram. I've got a problem to work here. We did a lot of that. Let's see, what's 214? Yeah, look at 214. Just remember what's on those axes is temperature and pressure. And spend a second looking at this. Right, so when things go from liquid to vapor, they're boiling. When they go from vapor to liquid, they're condensing. When they're crossing from vapor to solid and solid to vapor, they're doing these words, deposition and sublimation that we talked about a minute ago with the triangle thing there, and then melting and freezing are up here. So you need to know that. Supercritical fluids right here. Okay, get back familiar with that. And then you need to know that 4 is that's the triple point. Okay, so basic stuff that we covered, and points that are labeled here, just read back through it, and we'll go over some of that in our work session too. But you're gonna have to engage. Okay, you can't just check out and fill in blanks, because we're not doing a fill in blank final here. Okay, all right. Work these, find out what you know, what you don't know. I recommend taking notes on what you have problems with. I would have a separate sheet of paper and it says these are where I'm having trouble. Okay, because you're going to lose track of what you know and don't know if you don't write down what the problems are. Okay, so if you get stuck, if you can't do it, that's fine, but you need to note that somewhere, all in one place. So then once you're like, oh, that was super easy, I hadn't studied that in 6 weeks and I remembered it right off the bat, probably going to be fine on the test for that one. You probably don't need to spend a whole lot of time looking over it, okay? But if you get stuck on specific heat, say, and you just can't get that problem worked out, even if you end up getting the answer right in the end, you need to note that you had a real problem with that, okay? Just so that you can come back and say, all right, look, I need to ask about this, or I need to get with my friends and see what they did and if they can help me understand it a little bit better. And you don't spend a bunch of time talking about something you already know how to do, even though that's the easier thing to do. Okay. All right, converting between moles, grams, and molecules and volumes. I've got this number here, chapter 9, number 30. We've got ideal gas law, and so now we're getting into stuff that was pretty recent here, so you shouldn't have too much trouble. And you had that darn lab, that really made you engage with some of this stuff, so you shouldn't have too much trouble. That should be burned in your brain forever. But go back over it, work it. All right, work these numbers. It's going to apply to both of these. All right, calculating molarity and molality. Essentially, this is a definitional question, but you still need to be able to calculate them, okay? You don't know the difference between them, though, that's going to be a problem, okay? You need to be able to know which one's molarity and which one's molality. Look at the units, work the problems. Net ionic and spectator, okay? Remember what that is. That's where you've got, if you got something that starts in solution and ends in solution, like it's dissolved, and it's, we know it's dissolved because it's got that written next to it, aqueous. Okay, if they start aqueous and they end aqueous, they are just spectator ions. They are not involved in that reaction. Okay, go back, read, work. Okay, colligative properties, know what they are. Remember this word here. Okay, so, and I want to point out that, and I think I said this in the email to y'all, but anything that's down here, that's sort of like the core concept, like limiting reactant, for example. This is fair game for me to say the thing that runs out first in a chemical reaction is the what. You need to know that that's the limiting reactant. Okay, so just because it's not specifically located on the vocab list here does not mean that I can't ask you a vocabulary type question about it. Okay, so these are things that you won't really have to work anything but the very simplest equation. It's almost so simple that it's just the definition itself, right? Plug in this, plug in that, solve for that. If you don't know what the definition of it is, pressure is a force divided by an area. Well, as soon as you know the definition, you know this, right? All right, but these also include in them some definitional work just to know what they even are. Okay, I'm not going to ask you what is stoichiometry. Okay, I might ask you what is a limiting reactant though. Okay, or you might need to know which one is which on these. Okay, you need to know what molarity and molality is, just in a definitional sense, right? But you see how that's kind of like you can't even work with them unless you actually know the definition, so that's not really an issue, all right? Anyway, colligative properties, work this one. All right, and then calculating freezing point, depression, and boiling point elevation, which of course is, each of these is a specific example of a colligative property, and then we're going to work chapter 10, number 38. All right, so I want you guys to use the rest of the time and get working on these problems. I'm going to send out this list as well. So that you guys have it, and Aspirant has it, and then we will get together on Monday, and we will work through any issues, any questions answered. If well, just make good notes on what you've got questions on. Feel free to email me, and really make an effort to try and be there at the work session. I think it's going to be very helpful, and we're going to knock out a bunch of studying that is going to be really beneficial for you on the test. All right. So I will see you guys then. Email me or group me with any questions. All right. Talk to you soon.